Hi, in this video, we're going to look at the role of the IPv4 subnet mask. You'll get to understand the subnet mask in a little bit more detail. So here we have an IPv4 address, 192.168.100, and a subnet mask, 255.255.255.0. So it's the subnet mask. We look at it in binary there, that divide the network portion of the address from the host portion. So the ones indicate the network portion of the address, and the zeros indicate the host portion. Okay, so doing an operation that we refer to as an AND operation, we're going to look at that in a moment, it actually produces the IPv4 network address. So this is done using a Boolean AND operation. So, but as you can see here, where we have, let me grab my pen, where we have the 1 bits, it actually separates, where we have the 1 bits ending and the 0 bits beginning, separates the network portion from the host portion. And like I said, it's actually a Boolean AND operation that does this. So let's take a look. Boolean AND operations, okay? There's different Boolean operations. We're going to look at the AND one, but the AND operation is very simple, okay? Both input values must be true for the output to be true. For example, if I say Kermit is a frog and Miss Piggy is an actress, since both of those things are true, the entire statement is true. Okay, well, I mentioned that we used these truth tables to compute true and false. So first of all, take a look. I'm using zeros and ones. 0 is false, 1 is true. Okay, so if I say in this first one, false and false, that's an AND gate, by the way. And if we put both those values, inputs through an AND gate, false and false is false. So if I said Rick Graziani plays professional basketball and Rick Graziani is a millionaire, both of those things are false, believe it or not. So the output is false. Okay, let's take a look if one of the inputs is false and the other is true. False and true, oh, I added to the truth table there, okay. False and true is also false. So if I said Rick Graziani is a professional basketball player and Rick Graziani teaches at Cabrillo College, well, one of those is false and one is true. I think you can guess which is which. So the output is false. So we can add that to our truth table. And it doesn't matter the order of the true and false. If one is false, the whole statement is false. But if both input values are true, if I say Rick Graziani teaches at Cabrillo College and Rick Graziani also teaches at University of California, Santa Cruz, both of those values are true. Both those statements are true. Since both inputs are true, the output is true. And the truth table, we have a true. So both inputs must be true for the output to be true. Okay, let's see how we use this with our binary numbers. Okay, so there we see 1 and 1 is a 1. True and true is true. Everything else is false or 0. Okay, so there's our IPv4 address in binary. Here's our subnet mask in binary. Now what we're going to do is take a look take a look at each bit of the IPv4 address and its corresponding subnet mask bit, and then do an AND operation on it. Okay, so let's take a look. 1 and 1. Well, 1 and 1, true and true, is true. Okay, so we can do that again. 0 and 1. Oh, false and true is a false. Okay, so we just keep on doing this. So actually you can see wherever we have a 0 in our address, it's going to have to be in our IPv4 address, means it's going to be a 0 in the network portion. I'm going to show you a little trick here in the next slide, but let's just keep on going here. Okay, that's all the 1 bits in my subnet mask. Okay, do you notice anything in relationship with the IPv4 address and the network address? We'll take a look here. All right, so we have zeros now in the subnet mask. And because we have zeros in the subnet mask, guess what? All those values are going to be 0. So our network address is 192.168.1.0, and it will have the same subnet mask, 255.255.255.0. The key here is anything ended with 0 is a 0. Well, how can we make this a little simpler so I don't have to do this bit by bit? Real easy way to do this. All right, so here, excuse me, here is our same IPv4 address, 192.168.1.100, and the subnet mask 255.255.255.0. Here's a little, ending these two together gives us our network address, but it's really easy to do. All you have to do is this, 3 simple steps. Find the subnet mask and find where the 1s end and the 0s begin. Okay, right there. Okay, then, and I'm going to just draw a line down here. There we go. So everything to the left of the line has 1s in the subnet mask. Okay, so all we have to do is copy all these bits down here. So notice that the network portion here is the same as the network portion here. This is our IPv4 host address here, and this is, I should just write host, put an H there, host, and this is our network address down here. Of course, our host is going to have the same network bits as the network address. All the devices in this network will have the same network bits as the network address. What will be different is the host bits. Okay, but what we're doing here is just finding the network address. We copied the bits from our host IP address, IPv4 address, into the network portion of our network address. And network addresses, as we're going to see here more later, end in all zeros. The host portion is always all zeros. So we just put all zeros. Very easy to do. All right, let's take a look at a couple more examples here. Okay, so we saw 192.168.1.100 with a 255.255.255.0 mask. Okay, we copied the network bits. Okay, those where the 1 bits are in the subnet mask, and the rest were all zeros. Let's take a look at another example. Let's do 10.64.33.4. Okay, with this subnet mask, what do you think is the network address? Okay, well, let's take a look. All right, so our network address, very simple. We found where the 1s end and the 0s begin. We copied these to here, okay? Because our host is going to have the same network bits as our network address. Okay, then all we did was put all zeros here. We convert this, all of this, from binary to decimal, and we get 10.64.0.0. And this is the subnet mask, same subnet mask, only in slash notation, as our host. Okay. All right, let's take a look at a couple more. Just get the swing of this, the hang of this. Okay. 172.10.9.1. That's our host IPv4 address. Now, we don't know what network this belongs to until we find out what its subnet mask is. Okay, that's key. You need to know the subnet mask to know the network address of the host. Okay. That's why a host Any IPv4 device has an IPv4 address and a subnet mask, because that subnet mask indicates to the host, to the device, what network it belongs to. All right, so here's the subnet mask. What network do you think it belongs to? Yep, you got it. Okay, so we just copied the network bits here where the ones were, copied these 8 bits down here, and the rest were all zeros, right where the mask is. That gives us a network at 172.0.0.0. All right, so let's take a look at another one. Hey, wait a minute, Rick, this is the same one. Remember what I said? The subnet mask indicates what network it belongs to. Let's take a look. Ah, different mask. Okay, so if this device was, and all the other devices on this network had this mask, they would actually belong to a different network. So we changed the network, or the subnet mask, from 255.0.0.0/8 to a /16 255.255.0.0. Remember, the slash notation just tells us how many 1 bits are in the mask. Okay, so here we just copied the network bits here where the ones were. Okay, remember, just make that divided right there. Copied it down here, and then we put all zeros in the rest, and that gave us our network address. Okay. All right. Okay, so it's easy to determine, to find the network and host portions when the subnet mask falls on what we call a natural octet boundary. Natural octet boundary is like a /8, /16, or /24. It's very easy when, like in this case, well, 192.168.1.0 with a /24, there's the network portion, and there's the host portion. Okay, so we can even see that this is the host portion and this is the network portion. Here with a /16, we can see this is the network portion and this is the host portion. Put network there, host here. /8, network portion, host portion. /16, again, network portion, host portion. Very easy, right? Okay, we don't even have to convert it into binary. But you know what? That's not always the case. We don't always have subnet masks that fall on a natural octet boundary. Let's take a look. Okay, so our subnet masks are 8 bits, or 32 bits in length. We write them in dotted decimal notation. We take the 32 bits, divide it up into 4 8-bit octets, and express it in dotted decimal notation. But what can those valid subnet mask values look like? And remember, we always have to have a contiguous set of 1s followed by a contiguous set of 0s. Okay, so these are the only decimal values you'll ever see. Now, let me add one more, because there is actually one more decimal value you will see. Let me add that, which is a 0, okay, which is all zeros. Let me add that. Okay, there we go. So these are the only decimal values you will see in a subnet mask, because they have to be a contiguous string of 1s followed by a contiguous string of 0s. Okay. Well, let's take a look at what might be a valid subnet mask and what might be a non-valid subnet mask or invalid subnet mask. Okay, so tell me, which of these are valid and which are not valid? Okay, is 255 valid? Well, let's see. Those are all 1s, all 1s, all 1s, and all 0s. Yep, valid. Well, how about this one? 255, 0, 255. Those are all valid decimal numbers, but we have 1s here, 255, then 0s. Then we have 1s again. We can't have that. A subnet mask to be valid is all 1 bits followed by all 0 bits in the 32-bit subnet mask. So that's not valid. How about this? 255.255.240.0. Is 240 valid? Yeah, that's one of them. And then we have all zeros that follow it. That looks good. What if I did this? 255.255.240.254. Well, 240 is valid. So is 254, but because we have 240 here, we have some zeros, right? Then we can't have 254 because we have some ones that are following it. Nope. How about 255, 255, 255, 223? Well, that 223 is not a decimal number that if we convert it to binary would be all 1 bits followed by all zeros. It would have some ones, zeros, and then ones again. So this is invalid. How about this one? Yeah, all zeros is a valid subnet mask. Okay, so whoops. Let me get out of this here, clear that. There we go. Okay, so subnet masks do not always fall on a natural octet boundary. So here we have an IPv4 host address and a valid subnet mask. In this case, look where our ones and our zeros begin, right there. Remember Rick's rule? Simple, how we can convert or how we can find the network address. All we have to do is find where the ones end and the zeros begin in our subnet mask, copy all of these, okay, and then we put all zeros here. And this gives us our network address. So we just convert all of this binary here to decimal. And you see that the network address is 10.1.192.0. Looks a little different than here, doesn't it? We can't just easily see from looking at the host address that 10.1.193.140 is on the 10.1.192.0 network. Okay, we'll play around with this some more in later videos, and this will become more understanding to you, but I just want to make sure that you understand that subnet masks don't always fall on a natural octet boundary, and sometimes we have to convert it to binary to kind of figure out what network it belongs to. Maybe you're pretty good at doing these in your head, but it's always good to know how it's done. All right, so I hope this helps you understand a little bit about the role of the IPv4 subnet mask. Again, it's used with the IPv4 address so the device knows what network it belongs to. We must have that subnet mask. The IPv4 address by itself doesn't tell the device what network it belongs to. It needs the subnet mask to do that.